Here we're looking at finding confidence intervals. Now with this, let's look at what we have, and so we know which formulas we can use. Okay, a researcher wishes to estimate the average amount of money a person spends on lottery tickets each month. Okay, a sample of 50 people who play the lotto found the mean to be $19 and the standard deviation to be 6.8. Find the best point estimate of the population mean and the 95% confidence interval of the population mean. Alright, let's start out by listing what we do know, and then we'll come up with the formulas that we need. Alright, first of all, our sample size is 50, so they asked 50 people how much they spend on the lotto ticket. Okay, the mean for the sample size was X bar, which is $19. Okay, and then the standard deviation was 6.8. Okay, and so since we're given mean and standard deviation, we're going to end up using for our E value for our maximum error, we're going to use Z alpha sub 2 sigma over the square root of n. Okay, now we know it's at the 95% confidence interval, so at 95%, okay, we're going to use 1.96. Okay, so we're just going to set this up. We'll set it up as E is equal to 1.96 times sigma, which is 6.8, all divided by the square root of our sample size, which is 50. Alright, so we end up with 1.188. Well, we're going to round to one decimal place since our standard deviation had one decimal place. So we'll have 1.9. Okay, now to find our confidence interval, we'll take our mean for the sample size, and we're going to add 1.9 to it for the high end and subtract for the low end. Okay, so we'll set up for our true mean. We'll take the 19 and add 1.9, and we'll take 19 and subtract 1.9. Okay, so we end up with 17.1 or $17.10 and $20.90. Alright, so what does this tell us? It tells us that based off our sample size that we are 95% confident that the true mean for the people who buy lotto tickets, they spend somewhere between $17.1 and or $17.10 and $20.90 on lotto tickets per month. All right, we're looking at another example. Here we have we surveyed 30 adults and found that the mean average of a person's primary vehicle is 5.6 years, which if you did it today, it's probably a little bit more today. But anyway, based off some numbers from USA Today. Okay, assuming the standard deviation of the population is 0.8, find the best point estimate of the population mean and the 99% confidence interval of the population. Alright, so let's look at what we do know. We know N is 30, because that's how many adults were surveyed. Okay, we have a mean of 5.6 for the sample of those 30 people for their age of the car, and we have a standard deviation of 0.8. Okay, 99% confidence interval, Z alpha sub 2 is going to be equal to 2.58. Okay, so we're going to end up using the same formula we used before, because again we have mean and we have our sample size is bigger than 30. So for our maximum error, we'll end up with 2.58 times 0.8 divided by the square root of 30. Alright, so when we calculate all that, we get 0.376. Okay, I'm going to round, actually I'm going to round to this, because our standard deviation had one decimal place. So I'm going to round this to 0.4. So our maximum error is 0.4 of a year. Okay, so that's our maximum error. Now to come up with the confidence interval, okay, we're going to take 0.4 and add it to our mean of 5.6, and we'll subtract it from our mean of 5.6. Okay, so from the low end, on average, they're 5.2 years, and on the high end, 6 years. Okay, so this tells us that the true mean of all the cars is somewhere between 5.2 and 6 years old. Okay, based off our sample here.